Hello everyone, welcome back to Maths class, chapter number 25, Probability, the continued part of exercise 25b. Question number 10. A bag contains 16 colored balls, 6 are green, 7 are red and 3 are white. A ball is chosen without looking into the bag. Find the probability that the ball chosen is red, not red, white, not white, green or red, white or green, green or red or white. So let us understand this question. So there are 16 balls in which it is said that 6 are green, 7 are red and 3 are white balls. Hence the total possible outcomes will be equal to 16. 6 plus 7 plus 3. And the formula to find the probability remains the same. Let us concentrate on the sub-question. The first sub-question says, find the probability that the ball chosen is red. How many red balls are there? 7. Hence the number of favorable outcome is equal to 7 and the required probability is 7 by 16. Then find the probability that the ball chosen is not red. So try to understand this question, children. Out of 16 balls, 7 are red. So the difference between 16 and 7, 16 minus 7 is equal to 9. So 9 are the balls which are not red. Or this question should be understood by in other way, that is, not red means it can be green or white balls. So totally there are 6 green balls and 3 white balls. Hence the result is 9. And the required probability is equal to 9 by 16. And the sub question 3 is, find the probability that the ball chosen is white. How many white balls are there? 3. Hence the number of favorable outcome is equal to 3 and the required probability is 3 by 16. Next, find the probability that the ball chosen is not white. In the similar way, not white means out of total 16 balls, we can remove the number of white balls, that is 3 here. 16 minus 3 is equal to 13. This is not white balls. Or in other way, the sum of green and red balls can be considered as the number of balls which are not white, and the probability will be 13 by 16. The sub question 5, it is, find the probability that the ball chosen is green or red. So when there is a condition called or, it can be green or red. There is a choice. So we need to consider total number of green balls as well as total number of red balls. Hence the sum is 13 and the probability is 13 by 16. Next question, white or green. So consider total number of white balls and the total number of green balls. The sum is equal to 9 and the probability is equal to 9 by 16. And the next sub question is, last sub question. Find the probability that the ball chosen is green or red or white. So green or red or white means it is the total that is equal to 16. Hence the probability will be equal to 1. Next, question number 12. Question number 11 is similar type of question. Try to solve it by yourself, children. Let me move on to question number 12. A card is drawn from a pack of 52 cards. Find the probability that the card drawn is a red card, a black card, a spade, an ace, a black ace, ace of diamonds, not a club, a queen or a jack. So in the previous class also we have discussed about the playing cards. It has 52 cards. Hence the total number of all possible outcomes is equal to 52 and the formula remains the same. Completely with more attention, concentrate on the sub questions, children. The first sub question is, Find the probability that the card drawn is a red card. I hope you remember the chart. Out of 52 cards, we have 26 red and 26 black cards. Hence the 13 plus 13. 13 are heart which are in red color and 13 cards are of diamond which are also red in color. So out of 52, in a pack of 52 cards, 26 red cards and 26 black cards. So hence the probability is 26 by 52. Its value is equal to 1 by 2. In a similar way, a black card. Here 13 black cards which are of spade and 13 more black cards which are of club. Hence it is total is 26. Probability is 1 by 2. And the sub question 3, it is a spade. So out of 52 cards, how many cards are spade, children? So it is coming category wise category. So first there were 52 cards. Out of the 26 are red, 26 are black. So among the 26, where we get spade, how many spade cards are there? So it is equal to 13. Probability will be 13 by 52, which is equal to 1 by 4. And the next question is an ace. So for this, just observe this chart. This is only for your reference. How many ace cards are there in out of 52 cards, children? Ace card is a single card which appears in each category, that is spade, club, diamond and heart respectively. So hence in a pack of 52 cards, the favorable outcomes is equal to 4 and the probability is equal to 4 by 52, which is equal to 1 by 13. And next question is a black ace. So again there is two conditions. How many ace cards we finished? We came to know that there are 4 ace cards. So all the 4 are black? Of course not. There are only 2 black cards. So that is 2 by 52, which is equal to 1 by 26. I hope you are getting it, children. If not, kindly concentrate on the flow chart here. And the next sub question is ace of diamonds. So how many diamond cards are there, children? 13 diamond cards are there. In that, how many cards are ace? It is only 1 and only 1. Though hence the probability is 1 by 52. And the next sub question is not a club. So not a club means other than club, remaining how many categories are there? 3 categories. So 13 spade, 13 diamond, 13 heart. Its sum is equal to 39. Probability is 39 by 52. Its value is equal to 3 by 4. And the last sub question is a queen or a jack. So or a jack. Or means we need to include both. So there are 4 queen cards and 4 jack cards. Hence the sum is equal to 8. The probability will be equal to 8 by 52. Its simplified value is 2 by 13. By this we have completed question number 12. Let me move on to question number 13. 30 identical cards are marked with numbers 1 to 30. If one card is drawn at random, find the probability that it is a multiple of 4 or 6, a multiple of 3 and 5, a multiple of 3 or 5. So there are 30 cards marked from 1 to 30. Hence the total number of possible outcomes is equal to 30 and the formula remains the same. The first sub question says find the probability that it is a multiple of 4 or 6. Let us list out, children. See, 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, 4 6s are 24, 4 7s are 28. So these are all the multiples of 4. Which are the multiples of 6? 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24, 6 5s are 30. So it is written in an order. You need not to repeat. For example, 12 is a multiple of 4 as well as a multiple of 6. Again 24 is a multiple of 4 as well as a multiple of 6. So there is no necessary to repeat the multiples. So consider both the condition and list out all the elements. If you count, it is equal to 10. Hence the probability is 10 by 30. Its value is equal to 1 by 3. Now concentrate on second condition, that is the sub question 2. Find the probability that it is a multiple of 3 and 5. So when it is 3 and 5, both the conditions should satisfy. That means we need to choose a number which is a multiple of 3 as well as a multiple of 5. So let us list out, children. 1, it's not possible. 2, no. 3, no. 4, no. 5, no. 6, 7, 8, 9, no. 10, no. 11, 12, 13, 14, 15. So 15 is a multiple of 3 as well as a multiple of 5. In this way, you need to cross check for the numbers from 1 to 30. So there are only two possible outcomes, that is, one is 15 and the one is 30. So these two are the multiple of 3 as well as the multiple of 5. 3 5s are 15, 5 3s are 15. 3 10s are 30, 5 6s are 30. Hence the probability is 2 by 30, which is equal to 1 by 15. And the last sub question says a multiple of 3 or 5. So now a multiple of 3 or 5 means what I can do? If it is a multiple of 3, I can list out. If it is a multiple of 5, I can list out both the conditions. There is no condition that 3 also a number we need to choose which is a multiple of 3 as well as 5. I can list out all the multiples of 3 up to 1 to 30 and all the multiples of 5 from 1 to 30. If it is a common element, just write it down only for one time. So these are the numbers: 3, 5, 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, 3 7s are 21, 3 8s are 24, 3 9s are 27, 3 10s are 30. Then 5 1s are 5, 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 5s are 25, 5 6s are 30. So few are repeatedly. For example, 15 is repeated and 30 is repeated. So while if you count all the favorable outcomes, number of favorable outcomes is equal to 14. Hence the required probability is 14 by 30, which is equal to 7 by 15. Now question number 14. In a single throw of 2 dice, find the probability of a doublet, a number less than 3 on each dice, an odd number as a sum, a total of at most 10, an odd number on one dice and a number less than or equal to 4 on the other dice. So hence it is a single throw of 2 dice. We know that total possible outcomes is equal to 6 6 are 36 and the formula remains the same. So the first question is, what do you mean by a doublet? So a doublet means it is a number which is same on both the dice. So I have given the same chart for the output. See 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. So same number should appear on both the dice. It means a doublet. So there are 6 doublet outputs. Hence the probability is equal to 6 by 36, which is equal to 1 by 6. And the second sub question is a number less than 3 on each dice. Now we need to consider a number which is less than 3 on each dice. So I have marked out the output, children. See 1, 1 both are less than 3, 1, 2 both are less than 3. I cannot move to 1, 3, 4, 5, 6. Why? Because a number should be less than 3. Hence let me go to the second column, that is 2, 1 they are less than 3, 2, 2 they are also less than 3. remaining outputs cannot be considered because it does not satisfy the given condition. Hence, there are only 4 favorable outcomes and the probability is equal to 4 by 36, which is equal to 1 by 9. Next, find the probability that it is a total of at most 10. Children, at most 10. What do you mean by at most 10? That is, maximum is 10. It can be less than that also. It is the sub question 3 is an odd number as a sum. How nice the question is. If you add both the numbers on the dice, its sum should be equal to an odd number. Let us check, children. 1 plus 1 is 2, not possible. 1 plus 2, it is 3, take into consideration. 1 plus 3 is 4, then it is no. 1 plus 4, 5, it is an odd number. 1 plus 5, 6, it is not an odd number. 1 plus 6, it is 7, which is an odd number. 2 plus 1, it is 3, which is an odd number. Like this, add the values on both the dice. If the sum is equal to an odd number, then consider for the favorable outcomes. If not, neglect it. So, if you list out all the favorable outcomes, it is equal to 18 and the probability is equal to 18 by 36, which is equal to 1 by 2. And the fourth sub question is a total of at most 10. A total of at most 10 means minimum is not required, it is 0, but maximum is 10. The value should not cross 10, that is the meaning of the word at most 10. So, except 5, 6, it leads to 11, 6, 5, it leads to 7, 6, 6, it leads to 12. Other than these 3 values, all the remaining values can be considered for at most 10. The meaning of at most 10 is maximum is 10 and the minimum or other conditions will not be applied. Hence, we can take the values up to the number, the sum equal to 10. So, list out all the possible outcomes, that is 33, as there are only 3 unfavorable outcomes. So, the probability is equal to 33 by 36, which is equal to 11 by 12. And the last sub question, how nice the question is. An odd number on one dice and a number less than or equal to 4 on the other dice. See, children, only consider the first line 1, 1, 1, 2, 1, 3, 1, 4. In this case, 1 is an odd number and the other numbers 1, 2, 3 and 4 respectively, they are the values less than 4. But I have considered 1, 5 also. Why? Because in 1, 5, I can say that 5 is an odd number and 1 is a number which is less than 4. Hence, there are 5 outputs in the first column. I hope you understood this question, children. They did not mention that odd number should be on first dice and a number less than or equal to 4 on the other dice. There is no condition. The condition is among the 2 values, one should be an odd number and the other one should be a number which is less than or equal to 4. So, hence what we can do? So, in the first column 1, 1 to 1, 4, 1 is an odd number and 1, 2, 3, 4 are the numbers which are less than 4 and less than or equal to 4. And we have also considered 1, 5. Why? Because 5 is an odd number and 1 is a number which is less than 4. Consider the second column. In the second column also 2, 1, 2, 3, 2, 5. In this case 1, 3, 5 are the odd numbers and 2 is a number which is less than or equal to 4. In a similar manner, the third column, 3 comma 1 to 3 comma 4, 3 is an odd number and the numbers 1, 2, 3, 4 are the values which is less than or equal to 5. And in 3 comma 5, 5 is an odd number and 3 is a number which is less than or equal to 4. In the similar way, the fourth column 4 comma 1, 4 comma 3, 4 comma 5, 1, 3, 5 are the odd numbers. 1, 3, 5 are the odd numbers and 4 is a value which is less than or equal to 4. And in the last, that is fifth column 5 comma 1 to 5 comma 4, we cannot consider 5 comma 5 because 5 is an odd number and one more value 5 cannot be considered because the value should not exceed 4. If 1 is an odd number, then the other value should be less than or equal to 4. Hence, we are going to consider only the 4 values 5 comma 1 to 5 comma 4. In this case, 5 is considered as an odd number and the numbers 1, 2, 3, 4 are the values which is less than or equal to 4. So, list out all the favorable outcomes, children, and count down. Its value is equal to 20 and the probability is 20 by 36. Its simplified value is equal to 5 by 9. By this, we have completed exercise 25B. I hope you have understood this session, children. Thank you. Have a nice day.